a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. In more advanced business and science and technology problems, you're more than likely to see fractions used in combinations like this all at once, and usually messier than this. So our question is here, which of these operations do I do first? That is, in what order do I do my operations? Do you recall your order of operations from your previous chapter? Recall first we did inside the parentheses, then exponents as you come to them, then multiplications and or divisions as you come to them, then additions and or subtractions as you come to them. So let's apply that to this problem. First you get inside the parentheses. So we will stay here until this has been replaced by a single number. Once we're inside the parentheses, we look for exponents, then multiplications or divisions. That's an addition, so we skip it. There's a division, we do it first. Now it's between these two numbers, so we do it. So on scratch paper, recall that division means times the reciprocal of the divisor. And if you're multiplying, you look for cancellations, and that gives us 1/4 to replace this entire quantity there. So we did the division first. Then the rest of the problem we simply rewrote it as is so that we don't get confused as we begin crossing things out. Now staying within the parentheses, since all the multiplications or divisions have been done, the last thing we do is the additions and or subtractions as we come to them. Now are you beginning to memorize these? It's very important that you do so. So now looking for the additions or subtractions. Of course there's only an addition here, so we'll do that between these two, again on scratch paper. Here, getting common denominators, both of them into 8s, adding the numerators. This whole parentheses now has been replaced by 3/8. So doing so, we get this. And again, I've copied the remainder over so we don't get confused. Now that the parentheses has been replaced by a single number, in our order of operations we go back to the top and start over. We look for more parentheses. There aren't any. Back to the beginning and look for exponents. There aren't any. Back to the beginning and look for multiplications and or divisions. Okay, that's not one. Now remember, if a number is against a parentheses with nothing between them, a multiplication is implied. So there's a multiplication between the 1/4 and the results of the parentheses. So doing that on scratch paper, we get this. There is no possible cancellations, so multiplying tops for the new top, bottoms for the new bottom. 3/32 replaces this multiplication. Now that we've done that multiplication, we look for more multiplications or divisions. There aren't any. Back to the front, look for subtractions and or additions as you come to them. So I came to this first, so I must do this first before I do this. So doing this subtraction, again on scratch paper, we get this, but we must build these fractions to get the common denominator of 32, and we have 20 minus 3 is 17, so this subtraction is 17/32. And from this point on there's only one operation left, so getting common denominators here, which is 32 Adding the tops, we get 33. And if desirable, change it to a mixed number, which is 1 and 1/32. And we're done. Again, these rules for order of operation must be memorized as soon as possible if they haven't already. First, inside parentheses, then exponents, then times and divisions as you come to them, then back to the beginning, plus and or minus as you come to them, you're done. This is the order that will follow you through algebra, business math, calculator use, and computer use. This lesson will also ask us to review averaging, but in this case with fractions, mixed numbers, etc. Remember, if you're averaging, all you're going to do is add up the numbers, in this case 4 of them, and divide by the number of them. So we're going to take the sum of these 4 and divide by 4. Now if you feel more comfortable about adding in a vertical form, then by all means do so. However, with practice and experience, you will begin to prefer to do them horizontally, but that comes with practice. Now, looking for common denominators, looks like we're going to have 24. So I multiply top and bottom here by 8 to get 8 24s. Top and bottom here by 3 to get 15 24s. Multiplying top and bottom here by 6 to get 18 24s. Adding the numerators, and we get 16, 21, carry the 2, 41 24s, and 41 24s as a mixed number. And I'm going to do this the straightforward way, but we're going to back off and show there was a bit of a shortcut here. 41 24s. Traditionally, you're used to changing this to a mixed number. 41 divided by 24, 17 24s. So your answer is 17 24s and 1, which I will carry over to my whole numbers. So 1 and 2 is 3, 4 and 2 is 6. So this is the sum of these. Now let's pause here and see if this seems reasonable. 2 and 1 is 3, and almost another one is 4, 5, 6. So it should be a little bit more than 6, and this is a little bit more than 6. But once we have a sum, we'll divide the sum by the number of numbers, which is 4. So now we need to divide this by 4. So 6 and 17 24s divided by 4. Now to divide mixed numbers, we change both of them to fractions. But you notice here, I might just as well have left this as 41 24s and add these and get 5, because I'm going to have to change to an improper fraction anyway. But in this case, we'll do it here. So on scratch paper, 6 times 24 gives me 144, plus the top, which is 17. So I have 161 over 24s, and divided by 4 over 1 to write it as a fraction. So now when you divide, invert and multiply. There's no cancellation that can be done, so follow through on your multiplication, which is messy. So my answer, 161/96. Let's change that to a mixed number. 161 divided by 96 So my average of my four numbers is 1 and 65/96. Let's see if that seems reasonable. Now we're claiming that 1 and 65/96 is the average of these four. What do we know more elementary about average? First, it must be some number between the largest and the smallest. This at least rules out foolish mistakes. So we simply ask, is this some number between less than this and greater than this? And the answer is yes. So this might not be correct, but at least it's not an exorbitantly wrong number. And as it turns out, this is correct. The main way to check these, by the way, would be to multiply this times the number of numbers and see if you get the same number as you had in the sum. And if you check that, it does come out correct. Now, by reviewing order of operation and averaging, can you see you get a total review of the chapter? You'll be adding, subtracting, multiplying, and dividing all sorts of fractions. So this is a nice exercise to end our chapter. Therefore, let's use the bulk of the remaining time in this lesson to pick at the details of the order of operation and simultaneously to review fractions as a total package. Let's just take two operations at a time just to begin to get the relative order two at a time. So in this case, if I have an addition or subtraction, addition and a multiplication, the question is, which one do I do first? Multiplication always is done before addition unless a parenthesis intervenes otherwise. So I would do this portion as though this didn't even exist. And of course, when I'm multiplying, I always look to see if cancellation is possible anywhere. And in this case, it is right here. Then performing the multiplication, I get 5/8, and now put those results into the original problem and decide what to do next. In this case, there's only one addition. So getting common denominators very quickly, I have 4/8 plus 5/8 is 9/8. And if a mixed number is desirable, then change it to that. The point of this lesson is multiplications are done before addition or subtraction. And that holds, of course, between division and subtraction or addition. Let's do the addition again. That divisions and multiplications are always done before additions and or subtractions. So we pretend like this is the only portion of the problem that exists. And of course, when you're dividing, you're going to multiply instead by taking the reciprocal of the number that followed the division. See our chance for review here? Then now that it is a multiplication, I look to see if there is any cancellation, which there is between this 4 and this 6. Now note, there's sometimes a tendency to want to cancel up here, but I can't do that because I cannot cancel across division, addition, or subtraction. Just across multiplication only. Now, up and down in a single fraction, of course, I can do that anytime I want to because that's simple reduction. So now I have 3 times 3, or 9/10. Inserting that in the rest of the problem, adding, I think get common denominators, which in this case is 10. So I have 5 tenths plus 9 tenths is 19 tenths. And of course, as a mixed number, it's 1 and 9 tenths. Again, multiplications and divisions are always done before additions and subtractions, no matter where they occur within the expression. On the other hand, if you have multiplications and divisions, you do whichever comes first. So the division comes first, so I would do that first and then the multiplication. Had this been multiplication and this division, I would have done the multiplication first. But remember, division is a multiplication by the reciprocal of the number that was to have been divided. Now, when you have nothing but multiplications and divisions, there is a shortcut, which is simply this. After you've changed the divisions to multiplications, by taking the reciprocal of the number following the division, you now have 2 multiplications, and we can do that in a sense all at once. Now, what I mean by in a sense is we don't have to just isolate ourselves here to look for cancellations. We can look all the way down because everything now is multiplication. So we could see, for instance, that 8 goes into here once and to here twice. We can see that 2 goes into here once, into here twice. 3 goes into here 5, 3 goes into here 7, and all I have left on top are 5s and 1s, which 2 and 7 won't divide into. So I can finish my double multiplication of 5 times 5 times 1 is 25. And on the bottom I have 1 times 2 times 7, which is 14. And of course this changes to the mixed number 1 and 11 20/14ths. Now again, avoid these kind of pitfalls. There's a temptation, if you're not really thinking, to want to cancel here or here. One cannot cancel except across multiplications. However, be careful about canceling somewhere here too, because you're sort of assuming this is on top, when in fact it's going to end up being on the bottom, isn't it? So be very, very careful. Change your divisions first to multiplications, and if the resulting expression has all multiplications, then you can work throughout the entire series of multiplications to look for your cancellations wherever they occur, top for bottom. There's a similar shortcut when you're doing nothing but combinations of additions and subtractions. Again, technically you do the subtraction first because it came first. Had I had an addition first and then a subtraction, I would do the addition first. So addition subtraction wise, you do the operations as you come to them, reading left to right. And again, multiplication division wise, you do these two as you come to them, reading left to right. However, if there is nothing but additions and subtractions, in a sense you can do them all at once after you, of course, get common denominators, which we can see is going to be 16. So we can build the 8s to be 16ths by a 2. This already is 16. We can build the 2 by an 8. Then the top now becomes 14 minus 3 plus 8. So it looks as though we're doing all 3 at once, but really we're just setting it up at once, because the order of operations now to do the arithmetic of the numerator still requires that I do the subtraction first because it came first. Not because it's subtraction, but because it came before this. Had this been first, I would do it first. So 14 minus 3 is 11. 11 plus 8 is 19. And this changes to the mixed number 1 and 3/16. See, we're doing a lot of this simple arithmetic now mentally and very quickly. After all the exercise you've been through in this chapter, you not only should be able to follow it when someone does simple arithmetic quickly, you too should be able to do it just as fast. And I trust that you can. Consider this setup now, where we have an addition and a multiplication. In this case, the order of operations says we do the multiplications before we do addition. And the multiplication is between these two fractions as though this didn't exist. Now, we could have said that just the same with parentheses here, because by the rules of operations, we do whatever is in parentheses first. However, if the parentheses had not been there, we would do it first anyway. So usually the parentheses are not included unless they're absolutely needed. So inside here, we would see, because I'm multiplying, I'll look for cancellation up and down and across. And I do have a cancellation here, or division really. So that gives me 1 on top and 10 on the bottom. Now I think my way through the rest of the problem, rewriting it if it's helpful. And now addition-wise, I look for common denominators, which in this case would be 20. We can see to build 4 into 20, I need a 5 top and bottom. To build 10 into 20, I need a 2 factor top and bottom, so that this becomes now 15 20ths, and this becomes 2 20ths, which added gives me 17 20ths. Now, contrast this problem with the next one. It's very important that you see that this is now an entirely different problem. Here's the one we just did. There's a tendency for beginning students to sort of pretend like parentheses are invisible. And since 3/4 is first in both cases, followed by 1/8, then 4/5, with addition and multiplication in that order, to sort of assume that they're the same. But remember that parentheses says you are required to do this first. So in our first problem, because of the multiplication, I am obligated to do this before I do this. But now because of the parentheses, I'm obligated to do this, then multiply the results. So do realize that parentheses make a tremendous difference in mathematics. They change the whole nature of the problem. So now we're looking for a common denominator between 4 and 8, and we can just see that it's 8, which gives me now 6/8 plus 1/8 is 7/8. So the whole parentheses has become this one number, which now is to be multiplied times 4/5. And now because I'm multiplying, I can cancel either up or down or across. In this case, across the multiplication. And my results would be 7/10. Again, don't be tempted to cancel here, because you're not canceling across multiplication, you're also canceling across parentheses, and the only symbol you can cancel across is times. Except, of course, in the case where there is a single fraction within parentheses. So in this case, the parentheses don't say do me first. It's just a way of emphasizing that I want this number times this number. So realize that this expression and this expression mathematically are equivalent expressions. That is, I'll get the same results in each one. They're saying the same thing simply with a different symbol configuration. Sometimes we use parentheses in this manner to hold things together and to make it clearer, whereas sometimes a small dot can be somewhat confused. So this is the one case where you can cancel into parentheses. Of course, the cancellation law always applies up and down within a single fraction anytime, anywhere, in any problem. So in this case, I can divide this one by 2 and this one by 2, or had I preferred, I could have divided 16 into here once and 16 into here 3 times. But as it stands, I can divide this one by 8 and this one by 8. And I, in fact, am going across a multiplication to cancel. It's just that the multiplication is understood here and not generally written, whereas down here it has to be written. Okay, so finishing our multiplication here, I can divide 7 into this one once, 7 into this 5 times, and my final product is 5/6. Are you becoming just a little bit more comfortable with the use of parentheses now? You should. In formulas of business math and certainly in algebra, they're used very, very extensively. And finally, before we leave this lesson, remember that if you're going to average a series of numbers, that means you're going to add all in that series and then divide by the number in the series, which in this case is 3 numbers. So first adding these, getting common denominators first, which would change each of these into these equivalent fractions, then performing the additions, which would give me this sum. There's a tendency when you're not thinking in your hurry to quit at this point, and remembering that you not only must add the pieces being averaged, but then divide by the number of pieces. And remember that division by 3 is the same thing as multiplying by its reciprocal. So I would multiply by its reciprocal and in this case get 13/24, which is a number somewhat larger than a half because 12/24 is 1/2. Always remember that the average of a series of numbers must be larger than the smallest and smaller than the largest. So we know that the average of these must be a number greater than 3/8 and less than 3/4, and indeed this one is. This is your host, Bob Fennell. We'll see you on the next lesson.